So do you all have access to the virtual cluster that Victor set up? It should be accessible here through, I mean, you must have like a ReFramer XX username and then reframe.css.ch.
Yes, do have access, but
it should be empty basically if you are in. Let me see, there is a chat here.
But in the available modules, even ReFrame is not there.
There's no need. We're gonna do it everything from scratch.
Okay, all right.
So it's gonna be really. I would say, Victor, let's move. It's better if we use the chat of the Slack instead of the. And generally, I mean, the Slack channel from ReFrame inside the tutorial EUM'21.
So if you guys can ask questions there.
Yeah, because it's also better for formatting. And so let me just copy paste the link if you have not joined yet. I'm copying the link here, and then the channel you need to join is this one. So, I mean, we're already 5 minutes past. We can possibly start, and then if more people join. So first thing is, yeah, I mean, I hope you all have access. So if you have any problems, just type in the Slack channel, and there's also Victor in there who set up the cluster. So today generally in this tutorial series, we're gonna follow the tutorials. They are online, so they're just updated. So you should be here in 3.4, which is the version we're gonna use, basically the subsequent version, dev version Bob. So you might see 3.5 dev 0, but it's essentially the same. So we're gonna go through the tutorial, and I'm gonna adapt those tutorial exams to make them live on this ReFrame cluster. And along the way, I'm gonna show you how it is, and then you also practice along with me. So let's start. So the first thing is I'm gonna start really from scratch. I don't have anything here. It's empty as in everybody's. So, oh, sorry. So installing ReFrame and make it work is really pretty straightforward. So all you have to do is just clone it, get into the directory, and then there is a little script called Bootstrap that will basically install ReFrame's dependencies inside the installation directory of ReFrame. And the Python path, etc., they're not at all touched. So they're, So just ReFrame knows where to find its own dependencies. I'm going to show you in a moment. So it doesn't mess at all with the installation. Just a different way, instead of having its own dependencies in the repo, just have them inside it. So essentially it fetches everything inside this external directory using pip, etc. And there are also some options to the Bootstrap script in case you want to build the documentation, or if you want to use the Greylog bindings, which we're not going to look into this tutorial. So we're good to go with just this sequence of commands. So essentially here we have ReFrame. Everything is installed. Oh, I don't like this. That's it. So then there are alternative ways, either through easy build or through pip or through Spack. Any of those will work. The easiest is compare between easy build and Spack. I think it's easy build because Spack will really install the Python for you. Whereas in easy build, we're just using the system Python. So let's start. That's the very, very first example. So here is a hello world program, and here is the test. It's the one that I showed in the presentation, so it's really pretty simple. So all the tests in ReFrame, as I said, they're classes that they have to eventually derive from this class, the regression test class. There are also some subclasses. You can also subclass it yourself, but they have to eventually derive from that. Because it has all the logic of the test plus some meta class magic to do some fancy stuff. Then all the tests must define valid systems and valid program environments. If you don't, then ReFrame will skip the tests and it will issue a warning. If I'm not mistaken, we added this feature recently. And then in this particular case, you say, okay, here is your file that you need to compile. And after you compile, you run the executable you produced. And here you have an expression that says, okay, try to match this part in the standard output. Let's run it. That's the very simple example. So also here, by star, we mean that this test is valid for any programming environment, any valid system. So it will essentially run immediately. And by default, ReFrame comes with a configuration that will run on any system. We will see the configuration in a moment. So, yeah, I forgot that. Before running, let's see the structure, how this is structured. So, so you can have any type of directory structure you like, but at the lowest level, for example, in this one, you have your Python tests with your test files. And actually, you can have multiple ReFrame tests inside the Python file. It's not that here, just for illustration purposes, we're using one ReFrame file per test. And now inside that directory, inside that code, the directory structure, you have an SRC directory, where is your source code of the test resides. And here you can see the hello.c. So ReFrame, if you do this thing, it knows when it loads the test, it knows where the test resides. So it knows its prefix. And then it can look up inside the SRC for a hello.c. And then it will figure out also from the extension which compiler to use. And since it will produce the executable by itself, it knows the executable. So then it knows how to run it. And here is the basic of how you run. So essentially, when you start, ReFrame will load the configuration file from a set of locations we're going to see in a moment. And then you can pass with -c option the path either to a directory where test files exist or to a specific test file. And then you always need an action. So it's either a -l. Let's try the -l first. What is it? Yeah, sorry. That's from my previous testing. Sorry for that. So everything also is clean. So it's like you. So you can see here that you get a listing of the test that it found and where it was found. Some information here also, which was the settings file. I'm going to show you which one is the default. It's the built-in. And it doesn't show the built-in because you should not generally change that. So the built-in is here. The building, the built-in settings file. So let's run it. Okay, so that's it. It ran, and you can see that I ran on a system named generic on a partition named default, and using a built-in environment. Yes, the answer to Kenneth's question. So let's see what it produces. So generally, ReFrame, after it finishes, while it runs, it uses a state directory. We're going to see that in a moment. But when it finishes, it saves some files in the output directory, let's say, or archive. We just use output because that's what we have been using all the time. And it creates a directory structure there, like output, then the name of the system, then the partition, then the environment you run, and then the test. So here it just saves some files. So like the build script, it generated. Let's inspect them. So you see CC. So it really uses a generic compiler. That's the built-in environment. And what's the job script? Just run what you produced, and then you can have output. And actually, this is what inside the test the self.std out points to. And similarly. And then in your tests, you can also specify additional files to store. Now, one other thing that is relatively new. So for those that you have been using ReFrame for a while, I think since the previous release, we generate a JSON report with details. Now, by default, this goes to .reframe reports, and it's a single file that gets overwritten every time. But you can change the pattern so that every time you run a ReFrame, it generates a new one. If you open it, it's a JSON file with really all the details of the run. So the command line, when it started, elapsed time for the whole test, how many number of cases. And then you have for each of ReFrame runs, because ReFrame can retry, you can use ReFrame to retry failed checks, etc. And you can see the actual test cases it has run, job ID, all the details. So that's useful for debugging or for archiving or for keeping those if you want to process them later. And you can essentially, there is this report file option, which you can use. And then you can also have like session ID, I think it's called, JSON. So every time you run, then ReFrame will generate a new file, a new report. So let's see. So you see the my report, etc. for every time. Okay, now let's move on. I mean, if you think, yeah, you can interrupt me with questions if you want. So now let's move to another one. Let's extend our test to compile also for C++. And let's say we have, okay. Here I've shown you, we had another one. Okay, hello CPP, the same hello world. I mean, it might look very basic, but believe me, the hello world programs, especially if you go OpenMP, MPI, and then in combination, oh, they do reveal regressions. Okay, no, here we introduce a new concept. So before, you remember, we had the simple test, which essentially we wrap a test and that's it. Now here the test is exactly identical, except that we wrap it with parameterized test. Now parameterized test decorator takes a set of arguments, which is each argument of that decorator is a list of arguments to be passed to different instantiations of the test class. So in here you say the first time you tell to ReFrame instantiated with C, then with CPP. And actually ReFrame will instantiate multi-lang test one time with lang equals C, the other with equals CPP. And then you can use that as we do here and parameterize the test. So you don't have to define two tests or have inheritance or things like that. It's much easier. And it is very, very powerful because here you can have a function that generates those. And you can create any combinations you want. We're going to see some examples later on. So let's see how, now let's list the tests. So you see now that ReFrame also generates automatically a name for the test, which is currently a bit naively. So essentially it tries to convert to string whatever is the argument. And in doing so, it also converts any non-alphanumeric character to underscores. So in more complex cases, you might see some big names with lots of underscores, but it's something we're looking in ways of improving and allowing the users to define mappings, etc. But you can also set the name for yourself. But you should keep in mind that the names ReFrame, they must be unique, the names of the test, or the names of the test that ReFrame loads. So you can have tests with the same name, but if you don't load them at the same time, it's fine. If you do load them at the same time, then ReFrame will issue a warning, and I think it will either stop or or just ignore one of those. I don't remember. So let's run. Okay, so we have a failure. Now, here is a failure, the normal type. I mean, it's a failure. So whenever ReFrame failures, it gives you for each of the failed tests, it gives you more information. So here you see the stage directory. This is the working directory for each test. So basically ReFrame executes everything from that. So it copies any resources to it. And the idea is that this is like self-contained, so you can even tar it and give it like to a vendor if it's a self-contained test case. And then you have also how you can reproduce it. But here, if we go in the stage directory, basically we're not going to see anything special except for the files, which were copied from the resource directory of the test, the SRC. And the reason is that the error is a bit more fundamental, because ReFrame complains that it doesn't know how to compile a C++ program. Now, I think it's time that we look into the settings. Okay, so let's start. By default, I told you that ReFrame uses the default settings, which are here, which I'm going to copy in a settings that in a config that's called my settings, and let's inspect it. Now, here is the configuration. We're not going to focus on the logging for the moment. So it's, as I told you also in the talk, it's a big JSON file that is a JSON object that's stored inside the site configuration variable. You can also have it as a JSON file if you wish, but this is the Python format is more convenient if you want to dynamically generate stuff in the configuration file. So here is let's see the system. So here is the generic system, and it's pretty dumb. So it's say, okay, match any system that you run on. That's why it recognizes every system. So what ReFrame does when it launches, it issues host name, and it tries to match the host name in one of those host names that it finds in the different configuration entries, and it will pick the first match. Then each system defines partitions. And here we name one default that has the scheduler, which is local, that is, yeah, there's no scheduler. Launcher, which is local, that is just run the executable. And here are the environments that you should be testing on this partition. And here, these are just pure names. So here we have one called built-in. And then there is another section in that big object that's called environments, where you define the different environments. So there we define the built-in, and we have just CC. Now I'm not gonna change this. I'm gonna augment this configuration file with our own. So I'm gonna copy here. That's from my laptop, but I'm gonna adapt it to our case here. Okay, let's call it ReFrame EUM, the name of the cluster. Give it, the description is optional, but cluster. Now the host names here, I'm gonna do, I think it's ReFrame. Okay, and then we can even be a bit too strict. And partitions, let's name just one partition for the moment. The login is where we're running, scheduler local, launchers local. Now, I'm gonna still keep the built-in environment, but not exactly as it is this one. I'm gonna tell you why this is a good practice. And then let's define another one called GNU. Sorry, we didn't have licenses and stuff, so to install like Intel, etc. Now, let's define them. So we have one built-in, so ReFrame, but we need to redefine it. And actually, I'm gonna do it. I forgot something, sorry for that. One thing we need to do is we're gonna say that in this system, there is a module system and it's lmod. So then ReFrame, when you start putting in configuration or in test modules, it knows how to load them. If you don't put anything, it will simply ignore them. So, okay, wait a second, because I'm not that good VI user to automatically. Okay, so let's redefine built-in. Okay, and we redefined built-in, and we're gonna use here the built-in GCC that they are on the system. If you see, they are the 8.3 or something. And here we're gonna say that this definition is valid for the ReFrame EUM system only. So you can essentially redefine the environments as you wish. And then we say we have also the GCC environment, which I'm gonna copy this thing here. And here we call it GNU. And here, this stay the same. And actually one new thing is that for this one, we're gonna load, I think it's GCC 9.3.0. We can, or yeah, I'm gonna remove this for the moment just for plurality. And we're all set. So we have
Vasilis, there's a question about the built-in. I think you have built-in multiple times. So
yes,
asking, do you want a different name for that environment?
No, you don't need. So because here we restrict its scope. We say that when you're running on the ReFrame EUM system, the built-in is defined like that. And as a good practice, I would say that it's better if you define your environments with a standard name. So then it really makes standard way also of how you define your test. And then in the configuration, you specialize them for the different systems. For example, for another system, the GNU environment might be different, or yeah. So, or the FOSS environment later on in the examples that I'm going to show. And another reason is that we prefer keeping a built-in environment that doesn't load any module, is for tests that you don't want to compile anything. And in those cases, you don't need to load any software stack or any compilers. So if you just want to do some hostname checks or some system utilities or things like that. So only name plus target systems and current host affects which environment definition ends up being used. Yes. So the process is the following. So ReFrame, as I said, looks at the host name, then tries to match it in a system with these lists here. The first match it finds, it picks up the current system, in this case, ReFrame EUM as the current system. And here, it will start trying the different partitions we define. Now, for each partition, we say which environment we want to test. Now, here I know that I am on ReFrame EUM login partition, and I'm going to search for a definition for that. So first it will search for a built-in definition for the ReFrame EUM login partition. It doesn't find one. Then it goes for a definition in ReFrame EUM. So these are scoped, and in which case it found one. If not, it will fall back to the default built-in definition. So that's how it works. I think I'm done with the configuration. I think I saved. Okay, now let me see. Yes, everything is saved. Okay, now let's try to rerun. Now, one thing is with a -C uppercase option, you can point to your setting files, but for convenience, we're gonna export that to an environment variable. So here you see some differences. So now it says it picked up the ReFrame EUM system and now started to run on each of these systems partitions, which which we name login, and then using the different environments. So it took the one test and ran it twice here, and then the other test, and then run it twice. So remember, we have even a single class essentially, and we run already 4 times without changing anything. That's this nice thing about it. And now let's also inspect, just to show you in the output. Again, now you see we have a different system here appearing, different directory, login. Okay, I'm gonna pick this thing, then test RFM build, sh. And now you see, so ReFrame did a module load, used GCC, so it generated everything. Okay, now that's a convenience for the tutorial, but it's also good if you're loading ReFrame from a module file, then you can use environment variables to to change its behavior. But you should be careful with environment variables. You've seen that I messed up when I started because I had this environment variable set. Okay, so let's move on. So we now have a multi-threaded version of the hello world. I'm not going to go into the C++ code, but now let's have a look at this test. Okay, so here again, same things. Now we want to set some environment variables. some compilation flags. So the way to do that, ReFrame has what is called build systems. So you can specify what is the build system that ReFrame is going to use to build. And in this case, we define it's single source. That means that it has a simple file. It's just a single file that it must compile. And then there are several properties depending, they might change depending on the build system. So you define it here. Then there is some magic that essentially converts that to an object. So then you just say CXX flags, and we pass those flags. Now, we can also set the executable options, which with this thing here, ReFrame still knows which is the executable because it compiled it, so it knows which one it is, and then the Sanity pattern is the same. Okay, now I'm gonna try to run this. I took this example basically directly from Howard. Okay, we have a failure. So we have a failure, both of them failed. And the reason is build error, standard error can be found here. We don't, because compilation errors can be quite lengthy, we don't paste them here, but now that I'm thinking it twice, perhaps we can just truncate it and point you to the file. So anyway, let's see what the problem is. So let's go to the stage directory. Okay, so under this undefined reference. So yeah, the problem is that on my Mac this works, but generally we have to pass the minus p thread. Now I can do just that, and yeah, I will do for the moment just this thing to keep things simple. We could differentiate based on the programming environment, but that's later in the tutorial. And I think, okay, and now I'm going to rerun. Let me know if I'm going too fast or too slow. Okay, it seems to be happy. Now let's examine a bit the output because, okay, we have a multi-threaded test, but yeah, no, I'm gonna ReFrame EUM login. Let's pick GNU, and that's the threaded test. Why is it behaving so well? Okay, I like this more. I don't know why GCC 9 prints that nicely, but here the output is mangled. Obviously, I mean, our sanity check is too naive. So we're now gonna write a bit more, a slightly more robust sanity check. Just for demonstration purposes, I have everything in the hello2 MP, which this is what I'm going to use. So what we're doing here, now here we're demonstrating a bit this thing about expressions here, the sanity patterns. So before, you remember we had this SN assert found, and then a regular expression and the output file. So here we're a bit, what we're doing is we're actually counting the matches, and then we make sure that these are 16. Now, there is a whole library inside this package. It's all documented if you look into the documentation, sanity functions reference, that provides lots of utility functions. And here we say, okay, find all the matches of this in standard output. This produces back a list, which then we can take its length, and then we assign it here, and then we just make sure that this equals 16. Now, the nice thing about it and why you need to use those sanity functions is that none of those is evaluated here. none of these things. These are just deferred for a later stage in the test execution. Here it's just you're specifying where it's going to be, but you specify it in a very natural way. And let's run it. Okay, we hope that it fails now. Okay, so we get an error message. It's like, yeah, 14 not equal 16. It's usually, as you see in other testing frameworks like PyTest, but you can also adapt the message. But I'm going to skip that on how you can see the documentation on how you adapt the message. So you can have like number of found messages 14, whereas expected 16. It's arbitrary. You can have whatever you like. And then you see also the failing phase. It says sanity, so that you know it's a sanity problem. Okay, and now let's fix that. Again, just for demonstration purposes, it's a different file. So here, the trick is to add that program accepts a sync messages flag, which is a preprocessor flag. You can either pass it as CXX flags or in CPP flags. We just use the same convention as like the other build systems. Oh, sorry. And yeah, this as well. And there we are. It should be, everything should be fine. Okay. Now, let's run a performance test. So here I have the classic stream benchmark. Now let's go and see the new things introduced with this test. Now, we're fetching this test from its source. Now you can do that. There is this attribute called pre-built CMDs, which is a list of commands that you execute before running. And then same stuff, single source, stream to C, stream array size, different stuff here. We're just looking for this sanity pattern, and then, I forgot this. So there is also these variables, which is environment variables, obviously, that you can set. Those will be set both in the build phase and in the run phase. But you can, depending on where you define those, you can control in which phase they're only defined, but we're going to see how this can be achieved later. And here we have the so-called performance patterns. So here, the syntax is exactly the same. They use the same mechanism as with sanity patterns. And so you defined here performance variables like copy, scale, add, triad. You can have as many as you want or just one. And you tell ReFrame how to extract the value for that from the output. And here you say, that's your regular expression. And the trick here is that you use a capturing group. You can also name it. And then here you tell ReFrame which capturing group to extract, and you pass it also a conversion function. So the time that this comes out from ReFrame, from this extract single function, it will be a float. And then you can use that float and do whatever you like with it in Python code. So the same for scale, add, and triad. Now, let's run. Okay, this new option performance report will, if there is a performance test, it will print a summary at the end. So now you see that I haven't specified the configuration file, and they took it from the environment variable. So here you see the values we're getting, and none is for the unit because it couldn't find any unit. Now let's add some reference values. And actually, yeah, I'm just using 4 cores, but I don't remember. Yeah, let's stick to the. Let's don't open too many fronts. Now we're going to add reference values. Okay, to add reference values, this is the attribute that you have. So the self.reference, which is essentially contains different dictionaries, and the keys are the different systems. It can be also partitions. So, and you can have as many as you want. So I'm going to keep that. And here we're going to have for the login nodes. Now I think I know it's okay. It's a bit naive, but okay, and here are the thresholds. So the thresholds that you allow and say, if it is beyond those thresholds, -5 to +5%, issue an error. And actually here we can basically replace those with none. And that means if it's higher, don't issue an error. Only if it's lower than 5%. And I think we're set, and now we can run it. We can overrun the time, right, Kenneth, today?
Yeah, you're already overrunning 15 minutes, but yeah, it's not an issue. You can definitely go for another 15-20 minutes. Okay.
Yeah, everything's good now. You see, we have units because ReFrame figures them out from we specified those in the references. And by default, with the standard configuration that ReFrame comes with, which we copied for our config here, there is, every time a performance test is run, creates this directory, perflogs, and then it has ReFrame, the name of the system, the name of the partition, and then creates a file where it appends always the different runs. So here you might see more. It's better if I do it like that, because I was running also yesterday. But every time you run, it's going to be appending to this file. I'm not going to cover other aspects of sending, for example, to syslog or to Graylog, but you can see the documentation. There is one question in the chat. Okay, second and third values in reference are percentages always. Yes. You can't use actual values in that one, in the references. But if you want to use the references for, if you want to use it for doing a validation check, like you have GROMACS producing an energy, and then you want to make sure that this is within some bounds, you should not do that with the performance patterns. You can't do it with normal sanity patterns by combining them. Yeah, I forgot that. Okay, could you please share your My Settings file? Yeah, I forgot to tell you that basically, If you pull the repo, the final config is EUM'21. So that's contains everything that we're gonna build up during the tutorials. So it's this one. I'm copying and pasting here. Okay, now time to port this to an HPC cluster, which is supposed to be this one, which in the original example, I'm going from my laptop to Bitstain, but here we're gonna simply expand our config. Okay, so since we are in the same system, I'm not going to define a new system. I'm just going to define the partition that actually goes to the compute nodes. And I'm going to copy one partition from here and just adopt it. Oh. Okay, so let's name it this partition CN. These are, let's say, compute nodes. It has lerm, it uses SRAN. And now here, the access is how you get access to that partition. And in this case, it's a real partition, but it can be constraints, it can be anything. So in that case, you use a -p total. And here are the environments we're gonna test. Now, again, we're gonna use built-in GNU, but we need an MPI compiler as well. So we're gonna define an environment that we are gonna call FOSS. And then the max jobs is actually how many concurrent how many concurrent jobs ReFrame will run. And by default, it's 8, and we're gonna make it 10. Now, let's define also the FOSS here. FOSS. This is MPI CC, MPI CXX, and MPI F90. And here it is FOSS 2020A. That's it. Okay, now let's run the stream. Here it's much more because there is Intel, PGI, and everything. But in our case, it's much simpler. Okay, let's rerun some tests. Come on. Now, the -n option selects tests by name, and you can have patterns like here. So say any of those. We can even see them like that. Okay, now I'm running them. So you see they run on login, and then it tries the CN partition using now 3 environments. So the same test, we haven't even touched the test. It runs the 6 instances of the test they run now. Same for CPP, same for stream. And imagine how this could scale if you have multiple environments without even touching the test, except, for example, adding a supported environment in the test. Okay, and then we get also a report here. Now, let's also see what it was produced for the CN partition, right? Okay, I'm gonna pick the GNU again. RFM is here. Stream with ref. Okay, so you see, now you have a build script. Sorry, a job script with whatever is needed, the module loads, exports, anything. Now, for the same exact test, if I go here, I just get this one. So now, moving on, trying to adapt a bit the test to different programming environments and things like that. Yeah, give me a sign when I'm close to the end of the tutorial of the first one.
Keep going.
Okay, so let's now get this one, get here. Okay. So here we have the GNU already defined for our system, but I want also FOSS. So actually here you can have any number of programming environments. Which one of those will run depends on the system. Here you just have a big list, you can have a big list. Again, same things. Now, in our case, it's not so different, but for example, Dane, for example, each programming environment, you must have different compilation flags. So you need to differentiate the test behavior based on the programming environment it runs on. Now, to achieve this, first of all, I'm storing, this is not ReFrame, these flags. This is something that I defined. You can define it as you wish. The different flags, and let us also define for FOSS. And also we can even specify for the different partitions how many cores we want. And I'm going to use that, and for the ReFrame, the cores is also a test variable. It's not something from ReFrame. You name it as you wish. It's just a way of programming it. You can program it differently. Now ReFrame EUM login. I think here we are with 16 nodes. There is a feature request that the number of cores, etc., be defined in the configuration, which I supported, and it's going to be in sometime, so you won't have to do this thing. No, it's a feature request, not a pull request. And then on the compute nodes, yeah, we just have to. Now, let's see the juice.
Typo, ReFrame RAM, not EUM.
ReFrame, yeah, RAM, yeah, sorry. Okay, so now you need, in order to differentiate, ReFrame, while the test runs, define some variables, which is, there are 3 of them. So it's the current system, current partition, and current environment. Because you've seen that when we're running the test, it was taking the same test, it was essentially running into a different partition, different programming environment. So you can differentiate by just doing an if on those. There is a little tweak. Here, because those variables are not, except for the current system, except for the self-current system, all of those, the rest, current partition and current environment, are none when the test initialized. They're only set when the test has started to run. So that means entering the different phases of the pipeline, and especially after the setup phase. Now, for this reason, we have what we call the pipeline hook. So you can attach in every step of the pipeline. So imagine it just you can imagine as the lifetime of the test. It has a setup, then the build phase, then the run phase, the sanity phase, and the performance. And you can attach any number of functions before or after. So in this case, we want to set accordingly the compilation flags. So we name a function, we call it set flags here, and we set it to run before the compilation phase. Now we just pick the current environment name from the current environment .name, and then with that we index, we look up into this self.flags array, which is our array, and that's it. Now, same for setting the number of threads, the different environment variables. So again, we use the current partition here. We get the full name, which is the ReFrame EUM:CN or :login. And then we use that as the num CPUs per threads, and then we set the variables. Now, those variables will only be set when running the test, not when building. And that's the trick, for example, when you want to define some environment variables only when running. Now, I find this mechanism quite powerful because it's also very, very composable. Because you can have hooks, and then you can, in base classes that they are inherited, for example, from derived classes. Now let's run now. Let's run and let's see also. What we get? So it's the multi-sys test. Okay. So it runs on login, on CN using GNU. So we should be seeing FOSS as well. Okay. GNU, FOSS, I think, yeah, these are all of them. Yeah. We could even have built-in, but never mind. So now we can even go here and see output, ReFrame EUM'21. Let's pick the FOSS. Stream multi-sys test. Let's see the. So here you see the build script. We modulo wget mpicc, no other environment variable set. And here you have, because of the hooks, you just generate those here. And basically that concludes the tutorial for today. I hope you got an initial understanding of how ReFrame feels like. So I don't know if we have time for questions. I'm gonna be around in the Slack channel if you want to ask anything.
Yeah, we do have time for a couple of questions if anyone has a question they want to raise in the Zoom session. Or if not, as mentioned, maybe the Slack channel afterwards, and I guess throughout the day.
I will be available. I mean, yeah, but I've shown you here how exactly we got from the bare. I mean, as we cloned ReFrame, and we ended up, I don't know, in an hour, even going slowly because we had to demonstrate things and have it running some simple tests on on a cluster. And basically, I can get those tests and on pit-stained and run as shown here.
We have a question from Kapi.
Minimal changes. Yes, please.
Hey, thank you for a very nice presentation.
Thanks.
So my question is, are we linearly sort of planning to go over the whole, sort of read the docs as a tutorial, or are there sort of elements outside of it?
Yeah, there are new. I don't know if you have read the old ones. There's new stuff that is just published. Okay. My plan was that, yeah, to go over the tutorials which have now enhanced. I don't know if you were expecting something different or.
No, this is pretty good. I'm just asking the question. Because...
Yeah. So the plan is, the only thing is tomorrow we won't have so much. We will not be able to overrun. So I'll try to be faster.
There's no session tomorrow. It's Thursday and Friday.
Yeah, Thursday. Sorry.
Yeah.
Yeah. So the plan is to go over not the fourth one. I don't think we'll have time, but 2 and 3 to go through. And actually, there's some new stuff here that was added just in 3.4, like merged today.
Thanks.
You're welcome.
Okay, if there are no more questions, I suggest we can wrap up the session here.
Okay, so, thank you guys for attending.
The next session in this part for ReFrame is Thursday at 10:15 in the morning UTC.
Yeah.
So using the same Zoom link as you used today.
We have another one raising hand or not? No, it was.
No, I think.
Okay.
I think we're done. Yeah. So
Okay.
I'll end the stream. I'll end the recording.
Okay. Yeah.
Just one note: the cluster will be alive until the end of the week. So we will kill the cluster by the end of the week. Okay.